All right, section 17.3 goes into the molecular orbitals of dienes. This is something I skip in my course when I teach organic chemistry. Now, if your instructor talks about the Frost circle and really goes into the molecular orbitals of benzene, they're going to want you to know this material. So read the textbook very closely, okay? What I'm going to do is talk about the resonance of dienes and why they're very stable, okay? Now, this guy here is a diene and it's conjugated. So what that means is we can invoke a resonance to move the pi bonds from left to right like shown, okay? And what we get is a terrible resonance structure. So I'll show you why in a second. I think it's best if I draw in the H's here so we can kind of see the situation with the octet, okay? So the carbon on the left has no octet. The carbon on the right does have an octet. So this resonance structure is terrible, okay? The major contributor to the overall resonance hybrid is the original structure on the left. Why? Because there's less pi bonding, there's more charge separation, and I've violated the octet. I've ruined 3 things that were great about this molecule. But maybe it's only 2% of the contributing factor towards the overall resonance stabilization of this molecule. And that's enough to make conjugated dienes that much more stable, okay? We can also take the diene system here and move electrons to the right. To the left. So let me draw the starting structure here with all of the hydrogens so we can very carefully see what happens to the octet of these different atoms. And if I move the electrons from right to left, I can get a similar type of resonance structure. But now the carbocation is on the right and the carbanion is on the left. Okay. So once again, we're not saying these resonance structures are great. They're present. They're present in a very minute amount, maybe 2% of the average structure is represented by these charged structures, but that's enough to stabilize the diene, okay? This is a resonance view of how dienes are stabilized. It's not very compelling of an argument. The molecular orbital theory is a much more compelling argument, but as you can see in the textbook, it's much more complicated, okay? So that's all I want to talk about here for section 3.